Okay, if we want to summarize the graphical method main steps, first we need to find the feasible region as we discussed previously. Second, you need to plot the straight lines, which is called ISO value or ISO profit, ISO cost, whatever you call it. Those are straight lines based on the equations that are representing the constraints of your problem. So you draw those on your graph, then you slide the line in the direction of increasing value until it only touches the region, which means either maximizing or minimizing the value of the main equation. Then fourth step, you read off the optimal solution. So this is step number 3. You use a ruler to slide along your feasible region to be able to decide where is your optimal point, as we will discuss in the future, and where is your feasible region in that case. Okay, for now, for the topic of today, we will talk about an example or a problem on solving a linear programming model using the graphical method. So let's say we have an example in here. So this is an example without having any written form of that example, just for the sake of abbreviation and for the favor of time. Let's say we have a model that we created through a real-life problem with a set of constraints. This model is saying maximize 3x1 plus 2x2, where your constraints are as the following. So those are constraints. First constraint, you have x1 plus x2 less or equal to 80, 2x1 plus x2 less or equal to 100, x1 less or equal to 40, and x1 and x2 are positive values. So the question is saying find the feasible region for this model. For x1 and x2, if we look on the right in here, so x1, part of the constraints, x1 need to be a positive value, x2 need to be a positive value as well. So you need to have positive values. So for now, at this moment, the feasible region could be anywhere in the positive region of the Cartesian. So this is the positive region of the Cartesian. Could be bigger or smaller than this, just for the sake of illustration. Okay, now we have a general area in the positive side of the Cartesian graph. Now let's try to draw some lines. Let's represent those equations mentioned in the constraints, as we learned before how to draw those line equations into the graph and be able to decide the feasible region. First, we have the constraints saying x1 plus x2 less or equal to 80. As we mentioned in the previous lecture, you can assume that this equation is saying x1 plus x2 equals to 80, just for the sake of simplifying. And using the simple mathematics, find the slope and find the starting point and end point of your line, then you will have your line equation. So that line starts on the x-axis from this point and ends on the y-axis, which is x2 in this case, at this point. At this moment, the yellow region is our feasible region, but this is not our final feasible region. We will draw the other constraint line equations and see how it goes. We have another constraint saying x1 less or equal to 40. Again, we can assume that it says x1 equal to 40. Let's draw the line that represents x1 equal to 40. Let's use a ruler for that purpose. Okay. Let's put the ruler in here. Okay. Let's draw a straight line parallel to the y-axis, and that's representing x1 less or equal to 40, which can be said as the line equation of x1 equals 40. Okay, we have another constraint saying that 2x1 plus x2 less or equal to 100. So let's find the slope and start and end point for the equation 2x1 plus x2 equals 100. If we do that, we will find the starting point. Let's use the green in here. So we will find the starting point to be at 80 on the y-axis, and the end point, or the start point, that's a relative topic. End point will be somewhere on point 50. If we draw a straight line, let's use the ruler again. Let's draw a straight line between the 80 and the 50, and that will be our line equation. Okay, let's do that. All right, that's good. So this line represents 2x1 plus x2 less or equal to 100. With that being said, we can tell that this is minus, means this is not our feasible region. This is not our feasible region in here. Feasible region, so we said x1 less or equal to 40, so x1 should be somewhere here, and this guy is saying 2x1 plus x2 less or equal to 100, so it will be the region that he represents should be somewhere here, and this line is pointing in here. So our region is the region that's crossing, that's a common region between all the constraint lines. So if we would say, where is our region? So this is our feasible region for this exact problem. So the feasible region is represented by the y-axis and the x-axis represented as x1, y-axis represented as x2, and part of it is by the line with the equation of x1 less or equal to 40 and the equation 2x1 plus x2 less or equal to 100. So this is our feasible region that we are looking for. So this can be called feasible region for the equation maximize z. It was maximize z to equal 3x1 plus 2x2. So maximize the z, which equals 3 x1 plus 2x2. Then you had your feasible region for this exact problem. In the future, we will talk about the ultimate and extreme points and what can be done beyond the feasible region, and how you're gonna build the best representation for your maximized or minimized solution.